My name is, okay, yes. This session is recorded, as you noticed. Yeah, my name is Ville Tenhunen, and I'm data solutions architect in EGI Foundation, and I'm facilitating this session and so on. So welcome everyone. First couple of housekeeping information, and first I hand this virtual microphone to Bridget, who would like to say something about closing plenary session.
Yes, thanks, Ville. Just very quickly, there's been a slight change in the program. The closing plenary has been brought forward. It will now be at UTC 5:45 p.m. for half an hour. And then the drinks session, which has been organised by some attendees, will still take place at the time of UTC 6:30 p.m. Okay, thank you, Ville.
Okay, thank you. Then a couple of other things, collaborative notes. Please sign in. I'll put this collaborative notes links again into the chat, and you can find it there, and please sign in to the document, and it's allowed to make your own notes into the collaborative page, so we can share the notes of the session. Yeah, this session is also recorded, as you noticed earlier, and if you have any questions or comments and so on, you can raise the hand in here in the Zoom, or write the questions into the chat, and then we can have possibilities to discuss about these items. Our agenda is today a little bit it's flexible, and we have four interesting discussions and presentations. First is my short, actually fifth and first one is my short introduction, and then Mark Dietrich from EGI Foundation speaks about data ecosystems, data spaces, and data exchanges. Mark is a senior advisor in EGI Foundation. Then Juan Picarigui from Scientific Computer Department at SDFC UK. He's a head of this data division there, and he's speaking about EOS data spaces and these kind of things. Then we have a couple of use cases, one from ISNS, Professor Sandro Fieri from University of Trento, and then CDataNet and technical coordinator Dick Sharp from Maris. So, and then we have a discussion about items and possible next steps. Well, short introduction or motivation to this theme is, well, we are discussing here about data spaces, and when I started to thought that, okay, what kind of introduction to this session is okay, and I start to think actually my RDA plenary history shortly. My first RDA plenary was in Dublin, 2014, 7.5 years ago approximately. The theme of the plenary was the data sharing community playing your part. We discussed about data policy challenges on organizational level, practical policies for data sharing, data provenance and metadata issues, big data analytics, and then, for example, how about use Fedora for research data. This was a little bit how can I say, organizational level topics and issues, but the approach was this kind of organizational or trying to find the way to proceed with these data communities and so on. It was a third RDA plenary then. We still discuss about these issues, these concrete things, which is good, but of course there has been some development. We still discuss all about also like issues like metadata and local policy challenges. and these are important things and so on. But nowadays we have added some global context also to these discussions, or at least regional ones, like a continent level issues. We have a data commons and we have a data spaces, global open research commons, and these kind of initiatives in different places. I looked those programs of these plenaries before this meeting, and I noticed that the word global occurs 5 times in session names or descriptions of this plenary, what's going on right now. And in Dublin, the same number was actually 1. Okay, this is not statistically relevant information at all, but perhaps it gives a little bit some kind of weak signal about something. Somehow, these things reminds me some development steps of the World Wide Web beginning of 90s. When I started also these IT issues as a professional. First, we made those HTML pages manually and writing the code and published those pages. And then came some kind of online editors and web publishing systems. And we concentrated more on content and these things. Nowadays, all this is in clouds, in ecosystems, in communities. And Driver is not anymore doing those pages or publishing something as a web pages or something like that. But motivation is more on business drivers and this kind of business objectives, why we are here, what we are doing with this web thing. And actually, we are not doing this kind of classic web pages anymore so much. Perhaps something we can see with the research data. We started from the data and it was in the disk and we like to share it, and then came repositories, other tools and architectures, and now we are moving to the global page and ecosystems and this kind of thinking with the data, where we are discussing about more business driver level issues with the data than perhaps this kind of traditional details in techniques or technology and these things. Perhaps next step will be somehow AI powered systems, but it's another story, that one. And well, of course, there is all the time room for improvement and development on storages and metadata and these kind of technical details. But so data spaces, commons, data ecosystems, by definition, they are kind of cloud-based platforms where users can store, share, access, and interact with database on certain rules and processes and so on. But what kind of platforms or systems they are, is it perhaps this is one kind of starting point for this team. Not yet. I just collected some questions for this session. That okay, what is the nature of data spaces, commons, ecosystems? What are the differences and objectives with these? Is there general architecture point of view of these data spaces? What are the building blocks? What is the business architecture, information architecture, services, and so on? What are the user requirements for this data spaces or data commons and so on? Do we need this kind of global approach for these ones? And then if there is some need for the data space groups within the RDA, well, maybe we can discuss about also that one. Okay, thank you about that. And if there is not any urgent question, then I would like to stop my sharing and hand virtual microphone to our first speaker, who is Mark Dietrich from ETI Foundation. And so,
hello, everyone.
Please.
Thanks, Ville. And thanks everybody for joining us. This is I'm glad we can have the chance to get together and talk about this. Now I will now perform my my most advanced trick of the day, which is to share my screen. So let's see if we can make that work. And then do this. And do we have the right screen showing or no?
Yeah, I think so. Yes, looks
okay,
good.
Perfect. That's great. So to Ville's questions, I think I'm going to concentrate on the first bullet point. So part of what we're doing at EGI in thinking about data spaces and data ecosystems is to not get confused by the technical architecture, to try to look at some of the common characteristics, the common attributes that distinguish different kinds of data exchange activities, and use those to understand, to then understand the technical requirements and the technologies that might be used to implement them. So first, what these terms, data ecosystem and data space, they're being used more and more in business and by policymakers. Are not really terms that are commonly used by the research community, the research world. Data sharing and data exchange, creating open data. These are already and have been common objectives in research, and we've had the Rda Guiding Principles document. I think, I can't remember what the date was, 2014 or thereabouts. So that's kind of been the guiding principle in the research world. But outside of research, these words, data ecosystem and data space, are being used. And if you're from Europe, the data space concept is a huge topic for the European Commission. In fact, yesterday, they announced their Digital Europe program work plan for the first 2 years, and there's a significant amount of money being spent on creating data spaces in a wide range of economic sectors. So what does this mean for research? So what are some of the key characteristics? We'll try to talk about that. Let's explore some of the approaches that are being used by research communities, examine the mapping between research data and data spaces, and then think about what this might mean for the research community. So first, if you're looking at this, there are a lot of words, there are a lot of papers, there are a lot of documents, there's a lot of architectures and so on. There are a lot of people playing with this. I think it's worth mentioning very briefly the original meaning of data space. And I say this because Ville mentioned linked data. It arose almost exactly the same time as this idea of the web of linked data was raised by Tim Berners-Lee, I think, who is an early proponent of that. And the original idea of data spaces was a different way of sorting out the relationships between data. And that sort of got overwhelmed or overtaken by the idea of the web of linked data. And now we're talking about the web of fair data objects. And to some extent, data spaces and data ecosystems are about the data we would like to link, but perhaps we haven't. So the whole linking part may not be getting us to the point where we have all the data we want to do something or figure something out. So data spaces are a way of, or data ecosystems are a way of gathering a bunch of data together that we would love for it to all be linked and interoperable, but in fact it isn't yet. So how do we organize this and what do we do about that? So let's try to put some definitions together. So these are drawn from the literature. The first one in particular, a purposeful collaboration or partnership, consuming, producing, and providing interoperable data and related resources. So there are multiple data ecosystems and they already exist. So for example, in agriculture in Europe, there are 6, 7, 8 different agricultural data spaces, data ecosystems around Europe covering different parts of the agricultural value chain. They are not necessarily fair in terms of being findable, accessible, interoperable, and reusable. Similarly, science communities have their own data ecosystems. And although they generally want to be fair, they may not be there yet. So that's an objective. That's a journey that each science community is taking individually. Think of a virtual research ecosystem as a data ecosystem. It has built-in infrastructure that goes along with it. There's a desire for it to be findable, accessible, interoperable, and reusable, but fundamentally the focus is on stuff that works together within the virtual research ecosystem. Now let's kind of step back and look at the data space. And so EGI has proposed the following definition: a collection of fair plus quality data and related resources, infrastructure, that are consumed, produced, and provided by identified participants. In other words, they're not put out there anonymously, each respecting societal values and operating within an explicit framework of trust and governance. So this is not about open data. This is about fair data. This is about data that may have restrictions on it, that may need to be carefully used in a societal context or in a context of trust and governance. So the European Commission refers to a public data space, but you can actually use this definition in a private environment, even though fair is implicitly public. Let's kind of ignore that little detail for a moment. So in the European Commission's view, the public data space does not identify any actors or a community. They talk about a domain, perhaps. It doesn't have a specific purpose. It's just a bunch of data that's in an area that may or may not be useful to anybody. Nevertheless, the Commission aspires to create a single common European data space, as well as these domain data spaces. So one way of putting the two pieces together is to think of a data ecosystem as some sort of private data space. In other words, it's limited, plus community and purpose. So the thing that you lose when you go to a data space is community and purpose. But you gain visibility. So to sort of unify these concepts, we come up with, we're talking about data exchange approaches as being generic. So it has organizational policies and roles, plus technical specifications, and both are needed to enable trustworthy exchange of data between two parties. I say two parties because you exchange, it's A to B. There may be multiple parties involved in the data exchange approach. There may be multiple participants, but on any particular data exchange, there are two particular parties involved. And you see this in a research environment where you have material transfer agreements. The only exception to that is when it's open and it's published. So DEAs can flexibly describe different characteristics of exchange structures. And one of the most interesting characteristic is the visibility of the data. So how small or big is your community? How small or big is the group of people that you are exposing your metadata to and your data to, and making it accessible? So these are things worth thinking about as you think about your own science communities and the possible use of these terms. So a quick diversion. Some of you are familiar with the European Open Science Cloud. There's an architecture diagram, which I'm using here, and I'm calling out and marking in red a bunch of things that are basically data exchange approaches. So there's some that are very narrow up at the top: communities, clusters, regional collections. And then as you move down to the bottom, it becomes more of a common, open, publicly available capability. So what are some key characteristics? We talked about visibility and implicitly the security that makes that possible. Fair is clearly a piece of this, both for data ecosystems and data spaces. So we want things to be findable. We want them to be accessible, assuming we have the right to get there. We would love for things to be interoperable and to be reusable. We also want quality and fitness for use. This is something that has not been discussed in FAIR, but it's certainly something that is tremendously valuable and useful when we try to do something. And then all of this is done in the context of a trust framework, which I think has three components: community, who are we talking about? Purpose, why are we doing this? Why are we sharing the data? What's our purpose collectively? And what's the governance? What are the rules that we have all together agreed to when we're working with this data, either in a public environment, a fully open environment, or even in a more closed environment? So it works in both cases. So there's a spectrum of data exchange approaches, ranging from a one-to-one exchange agreement all the way to open data. So just to quickly illustrate this, I won't spend time on it. We will post this, so I won't go into detail, but basically you have an exchange agreement. There's an agreement between parties C and D to transfer data between them. So there's that agreement may cover all the issues that I mentioned a couple of slides ago in terms of its quality, its findability, its reusability, the purpose, etc. What can you do with it? When you go to a data ecosystem, which again is a community, a specific community, instead of vesting your trust in the agreement, you vest your trust in the rules that apply to the data ecosystem. So as a member of this community, you agree one time to the ecosystem's policies, rules, and specifications. There is a catalog that everybody can see. It's private to the data ecosystem, but it allows people, the participants, to see what's available inside the data ecosystem. And then once there's a decision, okay, I found some data, I want to get my access to it, then there's a mechanism that says, here are the ways in which you may use the data. In a research community, everybody talks about open data, general use for research, but in a private corporate or business environment, you can imagine a whole variety of specific exchange conditions being applied. The same for personal information, indigenous people information, endangered species, et cetera. So there may be all sorts of things, even when it's not commercial data. When you have two different ecosystems and members of each, separate members of each of these ecosystems want to exchange data, they have to ask themselves the questions of, are our respective rules, can they be harmonized? So what are the rules between the two data ecosystems? We're not actually saying we're going to put data from ecosystem 1 into the catalog of ecosystem 2. So what's going on there? And are there different sets of use conditions? So it's a little bit of an uncertain situation in this case. There are discussions about federation in order to harmonize these rules. So there's a set of rules for ecosystems themselves to agree to allow for the exchange of data between them. So there's a subset catalog of the data that may be available to both sets of ecosystem members, and some specific use conditions that apply within the federated data ecosystem. When we go to a public data, we get rid of all these different rules. Can everybody hear me still? Okay, thank you. And we still have to agree once to the rules in the data space. They may be more broad. We cannot rely on the purpose or the community. We have to assume a broader visibility to at least the metadata that we're talking about. So we may act differently. We may come up with different rules about how we expose our data because we know it's going to be publicly accessible, at least the metadata is going to be. And there may be a smaller number of possible use conditions that are broader, so broader reuse. And then finally, we have publishing open data, which all of you are very familiar with. We have a public metadata catalog, and we have a new thing, as opposed to a point-to-point exchange, we actually talk about a public data repository. So when there is a repository, we're kind of automatically getting ourselves into an open data environment, which is not necessarily the same as a data space or a data ecosystem. So data sovereignty or data autonomy are key issues here. Different data exchange approaches are distinct. They're not the same. So the fact that you as a researcher are participating in data exchange approach A or 1 doesn't mean you're automatically a part of all the others. So you have to make explicit sovereign decisions about where your data is going to go. Data our concept, data is exchanged rather than shared. In other words, you can publish it openly, but otherwise it's exchanged point to point. We need to think about bringing compute to the data, but that's a service. It's not data exchange. We also need to think about the role of data intermediaries who might collect data, be the recipient of exchanges from multiple parties, and then they produce a new thing, a new piece of data for people to take advantage of. So there's specific data exchange approaches along the spectrum. There are lots of examples in both research and industry of real data ecosystems with defined communities, defined governance principles, defined purposes. And they don't necessarily share all of their data with everyone. It's a not closed, but it's a limited community because this is the community that these researchers trust. It's not because there's a problem or they want to be private, but they're saying, okay, we know what these other colleagues in our disciplinary community are going to do with this data. We can trust them, and we're happy to put the data into that. As you move away from research, there are a number of other things. The IHAN initiative in Finland, X-Road, which is the Nordic countries in general, as well as the Baltics. European Open Science Cloud and Gaia-X, I would say, are both aspiring to be federated data ecosystems. And so Gaia-X, as an example, is explicitly saying that the different ecosystems that might exist within Gaia-X are separate. They're not all, it's not an all for one, one for all situation. They all have their separate existence, and there needs to be a careful discussion about what data might flow outside of a private data ecosystem into some other place. Public data space, data.europa.eu, the open data portal in Europe, is a good example, and there are certainly plenty of examples of open data. And here we have our colleagues talking about their own public data spaces. So in our examination of those use cases, we've determined that basically our two colleagues and a third from GBIF are all operating public data spaces. They didn't know they called themselves that, but they are. So it's absolutely meets all the criteria that the Commission would expect to see. So what do we do now? We recognize that research communities can use different data exchange approaches with different rules. Some will be true public data spaces, and some will be data ecosystems that are accessible only by their communities. Each will serve their distinct communities. They will have their own governance, and we have to respect the time and effort that has gone in to build those agreements and that governance within those communities. We want to find commonalities, and we hope that the characteristics that we've identified might provide a framework for comparing different data sharing, data exchange approaches in order to make it possible for greater interoperability. So our next steps are to expand our collaboration with other science communities and refine the framework, find additional points of commonality, and if anyone in the community, in the audience would like to throw in their own case study, we would be very interested in talking with you. So I think that is all. So thank you all.
Okay, thank you, Mark. Any questions to Mark? Point of view or comments? Yuri, please.
Hey, it's very difficult to discuss these quite wide topics in a remote way. I would prefer that we do this in face-to-face. At least we can do this in Science Park. So my question, very simple question, is currently what I proposed a concept and all approaches for me is not entirely matched to how in ITSA people are thinking. So I
think that's true, and in fact, I'm very familiar with IDSA, with International Data Spaces Association, and I've actually made this point to them to say their view that somehow magically the data that you put in gets exposed to everyone, as an example, and this is actually more possible than the other one, where there's more control by the owner of the data. This is a problem in their architecture. So I'd be happy to discuss this more. It's also possible that I do not have full understanding, so I admit I have to be humble in the limits of my own understanding of their architecture and their technology. But this is a topic that I think is extremely important. and which has not been properly considered by IDSA?
Because actually, I also studying and following, and we also met at common meetings at ITSA, the architecture. Also, we are not happy. We are doing research at University of Amsterdam on scientific data infrastructure, architecture development, exchange, and have kind of models also that not entirely say in a context of ITSA, but matching them, so compatible. So this is a problem in data spaces. Indeed, a lot of discussion, a lot of ideas, and indeed, correctly, this is definition of European Commission is not clear.
No, in fact, there is no definition. So it's not only not clear, it doesn't exist.
No, okay. If you look at the other writing of Horizon or European Commission, you can slightly extract context in which they do. But they again not match to ITSA. And one of the more specific question, you put EOSC as federated data ecosystem. For until now, I was thinking about EOSC as federated data infrastructure, the same as a Gaia-X represents them as federated data infrastructure. So infrastructure-wise ecosystem, at least it needs to be better clarified.
Yeah, I think, well, I would be happy. I would welcome the opportunity to have a conversation with you. I'm actually not in Science Park. So, and even if we were, we wouldn't be allowed to meet given the current restrictions, but I would be happy to have a meeting with you just to discuss these points in greater detail. I'm very interested, and Yuri, you and I have talked on prior occasions, so I hope we can have this conversation.
Yeah, we need to do something, because I understand you want to create an interest group or working group at RDA, or not?
Okay, we can continue about this group things a little bit later, and we have a short discussion. But thank you, Yuri, thank you, Mark. Now I would like to hand this virtual microphone to Juan Picaracui from UK, and he's speaking about also a little bit perhaps EOSC issues and then global approaches and these kind of things. So please, Juan.
Okay, thank you. Are you seeing the right screen?
Oh yes, very good.
Okay, thanks, and thanks especially to Mark, because Mark's just said all the things I'm going to say, and in much more detail than I'm going to say them. So in a way, all I'm doing is reiterating some of the points. I think it's pretty much exactly the same conclusions. Perhaps I'm asking a little bit more the why are we doing this rather than the what. So it's a little bit higher level. So I'm Juan Picaracui. As Vili said, I work at STFC at the Rutherford Appleton Laboratory in scientific computing, managing data from some big facilities. I've also been heavily involved in EOSC from the start. I was the coordinator of EOSC Pilot and a member of the executive board up until last year. In particular, I chaired the Rules of Participation Working Group up until last year. And as Mark was saying, the rules behind this governance of the data and of the sharing are crucial if things are going to work well. So I think that's relevant. And I was also involved in RDA from the start, being one of the people who kind of put it together. So what I'm going to do in this talk is all about why. So I'm going to recap on the aims very, very briefly of RDA, EOSC, and of European data spaces as I see them. I'm certainly not an expert on the European data spaces, so my understanding of that is quite high level. And we're going to see openness sharing come up a lot. So I'm going to think about what openness means and what sharing means and what we need to achieve each and why we're doing each one of those. And then really just ask some questions about how the concept of data spaces, as in the EC concept of data spaces, fits into this. We have to be careful in an RDA session to think globally, not entirely European. And looking at the names of the people attending, I think most of them are based in Europe. Obviously, I don't know everyone. But so let's keep throughout in our heads how these things work internationally outside of Europe. And I mean, one open question I've got, and I'll just put on the table at the start, is how data spaces that are intended, I mean, the definitions talk about within Europe, but if the multinational organizations are working within those spaces, you know, where is the boundary? Okay, so let's dive in. So just very briefly, if you've seen the RDA in a nutshell, I've pinched this slide from RDA in a nutshell. And I just want to pull out, hopefully everybody here understands the vision and the mission, but let's just look at that: openly sharing and reusing data, open sharing and I mean, it's pretty heavy, right? That comes up twice in 20 words. And then if we look at the next sort of banner, again, openly sharing data and openly sharing data is really, really what lies behind the RDA. So it's very important, I think, to understand what is meant by open and what is meant by sharing. And that's really what I'm trying to get to in this talk, and then apply it to data spaces. So a little older, this slide is a collage of slides from the first plenary in 2013. And I pulled this up again to try and remind us of what we're trying to do. And the bridge metaphor was one I was pushing very hard there at that time. And we talked about bridges to the future, bridges across partners, disciplines, regions, communities, in order to do things that we couldn't do before. But I'm going to focus particularly on what we do with respect to connecting data, with connecting people and connecting disciplines. And those are pretty much the same. I'm not sure if they're exactly the same 3 dimensions as Mark had, but they're pretty close. So let's think about those 3 things when we talk about openness and about sharing and what we need to do to enable the sharing. Right, so that was a long time ago. More relevant today is EOSC, and I've pulled out 2 definitions of EOSC here, one from now, one from 3 years ago. And again, just going to focus on particular words and see what comes up. The word open comes up here in a couple of places. I haven't highlighted them. Sharing does not come up, but because these are perhaps more about a bit higher level about what we're trying to do, a federated and open multidisciplinary environment is a phrase that is clearly worth thinking about, as is, and the last 2 lines actually giving us an idea of what it is that we're sharing. We've got storage, management, analysis, reuse of research data across borders and disciplines. So if I have to put EOSC on one slide, I think those 2 definitions probably cover what we're trying to do. Then data spaces. As I said, I'm not an expert on data spaces, but this is oops, sorry. I've blocked my own picture of my screen. I hope you can see it now. So here the word open doesn't come up, not surprising. And I don't think the word sharing appears on this slide either. But what are we doing? Well, if data can flow within EU and across sectors, that's clearly a kind of sharing. It talks about quality. It talks about the European rules and values are respected. So there's some kind of rule there. I think that kind of rule is probably a different thing from a data exchange agreement. But the idea, I think on the bottom left of the slide here, that the data spaces will facilitate the cross-border data sharing for business. There was a little bit in there about SMEs and the like, and the public sector. And there are 9 proposed on the table at the moment. in those domains there. And on the column on the left of the second picture basically says the same things as the 4 pieces of text on the left-hand picture. Sorry, something is stopping me advancing my slide. Oh. Now what's happened? Okay, so clearly those 9 domains that are mentioned under the data spaces are overlapping, and in the bigger picture it does talk about a single common data space across them. So maybe the long-term view is that all of those should overlap. And I think it's probably fairly clear that EOSC is a data space of a particular kind of data space that supports research. It isn't in that list for what I think are political reasons to do with how it's funded, rather than technical reasons about what the nature of it is. Right, so that's some background. Now, some thoughts about why being open is a good thing, and then we'll have some thoughts about why sharing is a good thing, and then see if those trying to achieve those sort of high-level objectives through data spaces fits within the scope of RDA. So for me, openness and open science is a means to an end. It's not an end in itself. That's the most important thing, right? Openness is a good thing without any doubt, because it achieves certain things. And here are some of the things that OECD have put down as things that you can achieve through openness in the scientific domain. So promoting more accurate verification of results, certainly, accelerating the speed of inquiry and discovery for the benefit of society, and that acceleration really comes by enabling bigger teams to collaborate more effectively, reduces duplication and the like, increases productivity, great innovation potential, that doesn't say why, and then the last 2, promotes citizens' trust in science and leads to active participation by a greater group. So and then on the right, I've just put there my own organization, UKRI, has open science as one of its objectives, and here you can see its reasons for that. It says it underpins the quality and efficiency of the research process by enabling easy sharing. Now, these OECD objectives or benefits, I think you could summarize with 3 ideas. You're going to improve the quality of the science, you're going to improve the efficiency of the science, and you're going to get a greater involvement of more people in the processes. So that is, I believe, my understanding of why openness is a good thing, because after all, we have to look for what the objective is rather than what the mechanism to achieve it is. Now, looking at sharing, well, sharing can mean many, many different things. We can be sharing something for a particular purpose. We can be sharing it within a group. We can be sharing it with some sort of compensation, which could be payment, or it could be recognition, or it could be on some reciprocation agreement where I'll share with you if you share with me. And in a way, those are kind of spheres of sharing we have to bear in mind. And a couple of thoughts here, probably slightly out of date, but when I first started in this whole open science area, there were quite a lot of groups out there who would not want to share at all. And the reason they would give is that they don't want unwanted sharing. So there's fear that once you share, you lose control, and then you don't know what's going to happen. Maybe it's data, or maybe it's tools, or whatever. So it's the easy way of ensuring that you don't get unwanted sharing is just to not to share at all, and then you have to control yourself. So if you are going to battle that, and share data, you need trust, whether that's backed up by a data sharing agreement or the rules of participation of EOSC or one of the other things that Mark was saying, requires that trust. Now, openness is a special kind of sharing, as Mark was saying, and open research, I believe, is therefore a special kind of data space. So how does this fit? This is the last couple of slides. How does this fit with the Rda Guiding Principles, where anybody can join Rda, provided they fit within these 6 underlying principles? My personal view here, well, openness, it depends what we're talking about. Are we talking about an open process or an open product where data could be seen as a product? And if we're talking about the product, what is open, to whom, and under what conditions? So there's some questions there. I think working by consensus, inclusiveness, and harmonization, those are definitely common objectives across this whole game. Community driven, well, that depends on who is the community. And so I've given it half a thumbs up there. And similarly for non-profit and technology neutral, well, non-profit, it's clear that the data space, the partners in data spaces in the European context are going to be companies that are in it for profit. So what is the non-profit element? Well, it's those activities that are happening in the data space, maybe they're done on a non-profit basis. They're not using the data space to create profit, but they're using it to set up an environment in which they can then make their profits. And probably the same with technology neutral, but these are really questions. I'm not putting these forward as answers. I think these are questions we should be looking at in this discussion. And then finally, just to try and put some of this into a picture, I think when we talk about sharing, we have to, and openness, we have to think about 3 things. What are we sharing? Who are we sharing with? And how are we sharing it? So for me, that's data, teams, and tools. And each one of these, there is a grayscale, as in Mark's spectrum that he had on for a couple of things on his slides. I think we can talk, there's a spectrum of things from actually sharing of data, sharing of metadata, access controls around that. There's sort of smaller teams and bigger communities, and there's specific tools for specific purposes, and then there's underlying technologies that are kind of multi-purpose and more generic. So I think each of these dimensions, there's a scale of different things that we need to consider. So really, I'm not answering any questions. I'm just putting some questions on the table for the discussion later. Thank you.
Yes, thank you, Juan. Any questions or comments? In chat, Volmar Nyberg Åkerström has commented that he haven't really heard data spaces used in the discussions around him before, and he's curious about if and how this differs from a global research commons as described in Rda Global Open Research Commons Interest Group, which is already existing group. That's a very good question.
I think that's a very good question. I was wondering about trying to put in a couple of slides about that. So the first thing is the domain. So Global Open Research Commons is about research, and I think they're focused on publicly funded research pretty much, and trying to harmonize across different commons, different open science commons that are happening in different regions. But the scope is probably publicly funded research, scientific research. Whereas the data spaces thing is much more general because it's much more geared towards industrial involvement. It's probably worth noting as an aside, looking back at the history of RDA, that it probably was expected at the start that there would be more industrial involvement, more commercial sector involvement. There is some, of course, particularly from the sectors who are supplying the research sector. But there's probably not as much industrial research going on in RDA or supported through RDA as we had originally imagined. So maybe this is a way of broadening out the scope of RDA. Mark, you've got your hand up.
Yeah, Mark, you have a
Yeah, I think I'm hoping, can you hear me?
Yeah.
Okay.
Yeah.
I've been having some technology problems here. So global open research commons, data spaces, et cetera. Let me throw out one discipline which in my personal experience has not been very big on sharing, and that's been the chemistry community. I know this is changing, but historically it was very much, you know, we do chemistry, we do some analyses of our chemical compounds, you know, we'll do characterizations and so on, and we'll shove them in our desk drawer and use them for our next research. But you'd have people fabricating, you know, developing the same compounds over and over again, doing the characterizations over and over again, the classic problems of not sharing. And I guess my point is that we talk about the global open research commons, but not everybody's doing it. There are, you know, there are individual researchers, there are communities that are less inclined to do this. So, and their natural milieu is okay, I'd rather work with my sort of my team, my coterie, my narrow community about organic compounds or what have you. I'm not necessarily interested in publishing everything for everybody. So not everybody's has matured to the point where they're making everything open. And I think the interesting thing, and we'll hear from Dick and Sandro in a moment, the interesting thing about those communities is they started in that mode as well. And it took them decades of work to get to the point where they're comfortable sharing certain kinds of data and publishing it openly. And they had to do a lot of work to get ready for that. So I think the concept of a data space and the concept of a data ecosystem reflects a lot of what's going on in science, who have not yet gotten to the point where there's a global open research commons. And I think there are plenty of people operating in that environment, and that's okay. I'm simply putting them into the spectrum so that we can kind of define what steps they might need to take to get there, to get to that global open part of GORC or GOSC. So so that's my thinking on that front.
You're muted, really. So
a comment on that, just say thank you a lot for elaborating on it and making it crystal clear to me why this is needed. I feel that it's really good, as you said, to have a voice of the non-research community and the people who don't work with open data as well. And I mean, having this kind of bridge between the two would probably be very useful as well. I mean, really considering that there might be at least some similar ideas on infrastructure, but the driving forces and the kind of end results might have different requirements if you're looking at commercial data and things that really should not be shared without restrictions.
Okay, thank you, Volmar. All right, let's go forward. We have two speakers and use cases going on. And first, Professor Sandro Luigi Fiore from University of Trento, and he's speaking about ISNS infrastructure for European Network for Earth System Modeling. So please, Sandro, floor is yours.
Thanks so much for that, and also Mark for the invitation. First of all, I will basically provide a very short view from a domain specific perspective. This is in particular from the NS community. So I will be just presenting a few slides talking about how the climate data space concept is being developed in our community. So before starting, let me introduce a little bit the community. So the ENES, the European Network for System Modeling, is a network of European groups working on climate research and Earth system modeling. This was launched in 2001. And one of the main projects from an infrastructural perspective that is supporting such community is called EasyNess. And we are now in the third phase of EasyNess. That is that started in 2019 and will end in 2022. So the EasyNess project as a whole started in 2009, and the project coordinator is Silvio Som from IPSL. So it's very important, the link between the two, because the EasyNess project with the three phases actually supports the community from an infrastructural perspective, and in particular it supports one of the main community experiments that is called CMIP, the Couple Model Intercomparison project, which delivered a lot of data to the whole community, which means tens of thousands of users that downloads data about this experiment from all around the world. And here we can see a little bit the history of this experiment. So we're now in phase number 6, and we started in the community started in 1995, and the CMIP one, there were just few data set, I would say, if we compare it with today's data volume, I would say 1 gigabyte of data, but at that time was already a big data like experiment. And now we are running to the phase number 6, and the data volume that we're dealing with is around 20 petabytes of data. So around 12 petabytes plus replica data sets. So this is a really huge amount of data that is just for this experiment, and the data related to this experiment are, I would say, behind the results of the ABCC report. So they are really relevant for the community, and they are of course relevant for the society as a whole. I would say that if we go through the whole through the different phases, we actually experienced also a lot of changes from an ICT perspective. For instance, from an infrastructural perspective, the way that we dealt with the data. For instance, while, for instance, in the CMIP3, data were centralized and hosted at PCMDI in Livermore, and with the CMIP5, we moved from centralized management of the data to a more distributed one. Actually, the idea was to manage the data in a federated fashion using a peer-to-peer approach. And this is the same approach, which of course is improving and extending a little bit also in the CMIP6 with, for instance, the replication of data with different like tiers, and so tier 1, tier 2, different responsibilities, service level agreements, and so on and so forth. And one important thing in CMIP6 is that data are open. So we provide open data as community to scientists worldwide. And this is an international effort. It's not just a European effort. There is a European contribution to an international effort. And when I mentioned before a federated data archive, I basically mentioned a set of the so-called data nodes that host data from the different modeling centers and provide this data to the entire community. Of course, part of this data, as said before, is being also replicated and to increase availability, and so to be more resilient to network issues or service issues, and so on and so forth. So here the link from the whole Earth System Grid federation that provide access to CMIP data to the community with the EasyNess project is that EasyNess provides the EU contribution to ESGF. So this is the European part of the international network hosting this kind of data. And if we just go into some of the statistics behind this federated archive, actually we see that there are more than 12 million of published data sets, more than 700 millions of downloads over the last few years, with 25 petabytes of data downloaded. So in what we can really see from these numbers is that there is a lot in terms of data movement, users that download the data in order to run then some data analysis on their own local machines. And this opens a lot of questions, of course, on the way that the data analysis is performed by scientists. And so there there are a few things that we need to think about, like, for instance, the fact that the data download is becoming a big barrier. So if we want to run a multimodal analysis using data from CMIP experiment downloaded from ESGF, it can take really a lot just to set up our input data for the analysis. It could take weeks in some cases. In some cases, it could take also months to get our data in place, ready for the analysis. And there are of course other issues that we need to consider if we want to think about like a data analysis process, like the fact that we need storage and computational resources. So we need the right capacity to do to store the data and to run the analysis, but we need also an ICT environment in terms of tools and the libraries that are needed for running analysis or experiment. And of course, we may also miss some automation tools for, I don't know, running workflows of analytics operators to implement some more complex data analysis. So there are these aspects that are quite important when we have to deal with so large amount of data in the climate domain, and that of course put barrier with respect to the client-side data analysis. And this is sort of thing that we want to address with the data space concept in the climate domain and in EOSC in particular. And this is something that we are actually defining and implementing in the context of a European project. We, I would say, as a community, the participating institutions to the EGIA's project and that are representing the community are IPSL and CMCC. So the idea here is to basically provide an open data science environment for scientists, where I would say I could link here to one of the last slides presented by Joan before, when we don't have just data, but we have also tools for analyzing this data. So there is a concept in the environment that we're thinking about, where of co-locating data and compute. Because if we really think about the climate data space as an open science environment for running climate research, then it's important to consider that I would say that with the ESGF infrastructure, we already, in terms of open science, we already achieved, I would say, the democratization of data. Because data are there. We have petabytes of data that can be accessed and downloaded by scientists, but we have not achieved the democratization of the analysis. And this is something where the climate data space could actually help in our domain. And well, the concept that is being developed in the EGIA's project is basically of a data space where we can, of course, provide ready-to-use data collections to end users. And this actually helps scientists by already providing data set for their own data analysis. And besides data set, they will also have the environment and so the tools for doing the analysis. And this is something that we think needs to be really tied. And so this is quite important. And in terms of environment, there are, of course, a lot of services that we want to provide in a way to somehow remove the barrier for end users about the IT environment to be set up. So this is actually a place where we host data, but we can also provide a way to act on this data. And from the EGIA's project, there has been like a first release just a couple of months ago. This is really the initial, the starting point for this, and there will be other releases that will be delivered every 5 months, pretty much throughout the entire project lifetime. And I think this was my last slide, just a couple of acknowledgements to two projects, EasyNess and EGIAs, that are actually providing the foundations both in terms of data repositories and also the link with EOSC that is very, very important for this work. Thank you for your attention.
Thank you, Sandro. Any questions or comments to Sandro? If not, we can continue discussion after the last speaker. And pardon?
Yuri raised his physical hand.
Yeah, this is it.
Physical.
hand.
Okay, Yuri, please.
Okay,
Yeah.
so I have a question to regarding which was slide climate data space in EOSC. What environment is expected to be provided for data space in EOSC? I find this list is quite consistent. But my question is, does EOSC provide all these elements to construct a data space, say subject or domain data space, like IDE, SaaS services, data science software stack? Does EOSC provide this, or will it provide?
Okay. Well, of course, the work that I mentioned before is is a concrete effort that is running in the context of the EGIA's project. And of course, there are some technologies that we are considering at different levels. And for instance, with respect to the cloud enabling technologies for the deployment of the applications, there are some that I listed in the overall architectural diagram, like EC3 or IAM, that we are using for deploying some of the applications that will be available in such data space. And this will be an environment available to, this is an environment available to scientists. So this is online, and there is an interface for registration, and there is a preliminary set of data that can be accessed. And of course, in terms of software stack, this is something that will develop with the community. Actually, I would say there are two things that will be developed jointly with the community. One is the software stack in terms of tools for the end users, and the other thing is, and the other one is the set of data that will be available. So we'll basically follow requests from the users in order to populate the data space with the most relevant data. And in terms of tools, there will be several software stack releases that will include tools based on the input from the climate scientist. So if we think about the tools, they come from the climate community. If we talk about the cloud technologies for the deployment of the applications in the cloud, they come from European partners that are developing in EOSC cloud technologies. And I mentioned just a couple because we are using, for instance, from UPV, a couple of technologies for the deployment of applications.
Okay, thank you.
Okay, thank you, Sandro. Thank you, Yuri. Okay, now the last use case, last speaker, but not least, Dick Sharp from Maris, and he's a technical coordinator of the C.NET. Please, the floor is yours, Dick.
Hi, first of all, thank you for inviting me, and also for this interesting discussion, because data spaces, let's say, we're also confronted with these terms, let's say, and we have to find a way, of course, in our applications for new proposals. I will tell you about C.NET, and C.NET is something that, in fact, I was working on this since the 80s, let's say, in the third framework program, and we are now, as you know, the 8th framework program, so it's quite a while that we have been working on this. Let's see, is it working? Yeah. Now, first of all, let's say we are in the ocean and marine domain, and as you might know, of course, the ocean marine domain is the largest part of the world, of the globe. And it's very important for many, many different things like our climate, our energy, our food, our tourism, trade, health. So it's really, it's for society. It's not only for science, but of course there's a lot of science going on, let's say, to understand this environment. And for this, let's say in Europe, we spend quite a lot of money every year on collecting data from the seas and the oceans. And we use many technologies, let's say, to be able to do this. And there was an assessment a few years ago where we said we spent about 1.4 billion euro a year simply to get a lot of data. And that means that also we need good data management infrastructures to be able to do something with this data and to reuse it in many ways. And therefore, over time, especially with support from the Commission, of course, the EU RTD program mostly, we have built up quite a good infrastructure. And if you look on the left in this poster, you see there are 3 layers, you would say. One is those who are collecting the data. And as I said, there are many ways to collect data, and it's not only done by government and by science, but also done by companies, industry. Then we have in the middle, we have a number of aggregators, which are infrastructures that have been set up to better manage the incoming data and to make it fit for long-term storage and use, but also looking at quality control, validations. And then on top, let's say we have the users, where we always distinguish between intermediate users and the end users. And the intermediate users, let's say that's anybody who adds value to the data. Let's say they can make different products and different services, which are then serving a certain purpose, which of course also science, but also governance. And so we are in this picture, as you see, we are serving more or less the environment, good management, science, but also the blue economy. If you look at the aggregators, let's say there are several research infrastructures over time that have been developed also with the help of the Commission. But there are three, let's say, leading ones, which one is CDataNet, which is for in situ data. That's a network of the National Oceanographic Data Centers. There's ABOTnet, which is an initiative, a top-down initiative from DG Mare, which has been running now for 10 years and is more focused on, let's say, making products, generic products for Europe. And to be able to do so, of course, they need a lot of data. So there's a clear cooperation from ABOTnet with all the different research infrastructures and with CDataNet. And then there is Copernicus. Copernicus especially aims, let's say, at making products from the satellite programs, like Sentinel and others, and also using big models. So you can say we have the past, the present, and the future in this picture. And so we are able to understand the systems of the sea and the oceans, but also we're able to do forecasts more and more. And all these processes are very data hungry. So we have to organize the data very well. Now, CData is what I'm talking about. Is we started this, like I say, in the early days, and with several, let's say, framework programs. We got ongoing support. And over time, also the network, let's say, developed more and more. So we went from metadata to data products. And now we are more and more also machine services and cloud and virtual research environments. So there's more and more happening with the data. It was started by what we call the NODCs, the National Oceanographic Data Centers in Europe, but over time, more and more also marine environmental monitoring agencies and other national hydrographic services, national geological service, all, let's say, they start getting connected by means of various projects, spin-off projects, but also simply by the ABOTnet push. We have a portal, and the portal has 2 sides. It serves data managers, data providers, with a lot of tools and standards. And on the other side, we have the users, and the users, there's a lot of services and services which, products, etc., they can use, and also tools for analysis that they can use from the portal to be able to do something with the data that we provide. Common standards is one of the key issues that we started with. So let's say it's a little bit like the oil that makes us streamlines the process. And we started working on metadata formats already a long time ago, before there was even somebody was speaking about FAIR. Let's say we were already working on FAIR a long time ago, decades earlier. And it's for, we set up meta formats for a real set, like data sets for research cruises, for monitoring networks and research projects. And it's a little bit like, we have an organization can be involved in the project. The project, they can collect data for the data they use monitoring. And in the end, they produce results. And that's how we look at the system. And also we have standard formats because we would like to harmonize the exchange of data. And CData itself is in fact an exchange network. So because we are based upon these national data centers, but we bring it together in a common interface, a common index, and then from there also, let's say, a common way of providing the data, all supported by controlled vocabularies. And that was also one of the things that we started early on. These are the BODC vocabularies. So there are many lists to code all the metadata tags and the data tags that we have, so that we can speak a common language, but also so it's machine actionable. And that's really important. And those vocabularies are now used also worldwide, because more and more organizations in the marine and ocean domain understood that it would be a great way forward if they would join those vocabularies and add flavor to them, add content, instead of setting up competing lists. And the same we are doing, let's say, for instance, in chemistry, we are using, let's say, already existing lists, because there are so many chemical terms, and we embedded them in our own vocabularies. And by doing this, let's say, we developed the capability to handle many different data types for chemistry, physics, geology, geophysics, and biology in the marine domain. And this is still going on, because every time there are new technologies by which people are collecting data, and it could be on the microscopic scale, it could also be on the macro scale. But anyway, we have to deal with these data sets. And what we try to do is use as much as possible our common formats, but then make them also fit to handle those data types. And the same for the vocabularies. The vocabularies are enriched with new terms by which they can, again, help us to speak the same language. So this, for instance, an example of the vocabularies, just to show you that there are many ways to find data and also to build new terms. We have a whole set of European directories, which is like an organization doing a project, doing a cruise, collecting data, having an observatory, and producing larger data sets or managing larger data sets. And these are all for working according to the linked data principle. So we're using each of them also to mark up metadata and data, but also they are supported by these controlled vocabularies. And over time, we went from, let's say, GUIs, graphical user interface, more and more also to machine services. So web services, Sparkle, APIs, etc. Because that's nowadays, let's say, asked to work efficiently in this marine data community, where we have so many, let's say, endpoints, but also so many uptake points where people have to code and ingest their data. And there's more and more done with supported, of course, by services. A central service for us is what we call the CDI, the Common Data Index, which is a data discovery and access service. It's based upon an ISO model, the 19115, 19139. And over time, let's say we started with having a network and everybody is connected. And in the beginning, we only had a common, let's say, a common metadata base. And there was a tool to be able to shop for the data by each of the individual data centers. But recently, as part of the CData Cloud project, we built up a data cloud, let's say a cache, by which all the open data is replicated to a central cloud. And this, of course, means now that we now have an independency between the front and the back office. So we can deliver data from the let's say, from the warehouse or from the cloud, while maybe the connections to a data center might have some issues. While in the past, this was, let's say, the weakest, I call it in a chain, the weakest notice can give you a problem. But in this case, we overcome this. And also what we see is that more and more, let's say, we have more open data or public data, unrestricted data. So we work nowadays with the CC BY 4.0. And we see that a lot of, let's say, communities, in our case, discipline communities, let's say, that were a little bit, let's say, I called, they were a little bit afraid of going fully open. They are now bringing more and more data in the open space because others are doing it also, and because it's so easy and visible, and they understand it's no longer competition for them, but it's more they have to be present. And it's an interesting, how this turned over time. So right now we have about 10% which is restricted, and that's because of scientific embargoes, for instance, moratorium, or it's because the data itself is quite sensitive, like seismic or like hydrography. And then the owners, they first would like to see what is the purpose that people want to use it for. And then they can decide and put a switch in the system by which they can access the data as well. So this system is, currently we have more than 2.5 million entries. from 114 data centers all over the European seas, 34 countries. And more importantly, we also have 850 data originators, and those are universities, that could be research institutes, it could be individual researchers, but there are also companies and industry partners and governments, monitoring agencies and so on, who bring in their data. And this is like a little bit like a snowball. Let's say once it runs, then people are more and more convinced of that the effort has an impact, and also they are more and more users themselves. It's a little bit like what you put in, but you also take out. So it's give and take. And there are this is on the front end, but just we also make available a lot of software tools to make the system easy, both for ingestion, to convert your own local data, let's say, to the common formats and the metadata, but also to use the data and also to make not only delayed mode, but also, let's say, real-time data exchange possible with operational stations like wave buoys, sea level stations, etc. And this is also very interesting. Also, we have a lot of cooperations, of course, let's say over time on a global scale, but also in Europe and with many projects and together with Copernicus and EMUNET. And if you look at EMUNET, EMUNET was gave us another momentum, I would say, because EMUNET was started in 2008, and it was an idea by DG Mare, so a different unit of the EU, and they want to make an overarching system. And we soon we qualified, let's say, as a major supporting data infrastructure, because they want maybe to reinvent the wheel, and we could withhold this. and now, let's say, EMUNET is especially focusing on developing data products and services in support of the blue economy, the blue environment, and marine knowledge. And this is done by several thematic portals. But all these portals, they need data, and the data is organized by the existing infrastructures like CDataNet and Eurobis. And of course, the effect was there was a win-win situation, because this is a top-down approach, and that meant that a lot of member states were very interested to join EMUNET. And to join, they had to adopt the standards and the services and the approaches that we have in those underlying infrastructures. And this gave, let's say, gave a lot of momentum. So we went from about 50 data centers, we went to 110, 114 right now, because they had to be connected. These are some of those products that you then can make. You can make, we do now eutrophication, contaminants, and marine pollution all over Europe, the European seas. But we also do, let's say, a digital map for the highest digital bathymetry for Europe, all the European seas, by bringing together all the survey data from bathymetry that are being collected by the National Hydrographic Services, but also by research institutes. And again, having a very nice cross-fertilization, I would say, between people that are tasked with a certain operation, let's say, from a management purpose, and those who are more doing science. And the cross-fertilization is really wonderful. And also, we are not thinking anymore that we only work for science, but we work really for society, and that is more and more the case. Another one that we, from this, let's say, because there is the data space approach, and that's why the Commission also set out a call for, what they call a flagship call in support of the UN Decade of the Oceans and the futures of the oceans, the G7 initiative. And the idea was, let's say, looking also at EOSC, of course, let's say, to set up a thematic EOSC, a blueprint for a thematic EOSC by the marine community. And in fact, deploying a cyber platform with a smart federation of the data repositories, the analytical tools, and the computing facilities, and to see how this could work out. And this works, let's say, according to this principle that we have already, or we had already, let's say, the pyramid at the bottom, which is discovery and access, and bringing together a lot of data from many different data sources by applying common standards for the formats and for the vocabs, and also for the quality control. And now we added, let's say, the pyramid on the top, which is getting bigger and bigger, which is more and more applications in the cloud, also with Docker installs and whatever, let's say, to be able to analyze the data and make workflows, which then support really decision processes and also are in support of very challenging science questions. And this is in the Blue Cloud, we do that on a large scale. And first thing we set up is now a discovery and access service, sort of overarching over various of those existing repositories, but fully based upon machine-to-machine operations. Then we have a virtual research environment which is quite extensive. And it also, one part of this is the DIAS, let's say, from Mercator, the Copernicus virtual research environment. And we have set up several virtual labs for specific science questions, and they serve as demonstrators, but especially as demonstrators to show that this concept can work, and also that it can work for open science, because there's a collaborative element here, because the virtual labs are open for others to join and to work with the same algorithms and to apply their own calculations and computations. And it's in this sense, there is also what we call a roadmap development here. So we do a roadshow, and we have a lot of interviews and with stakeholders from the top, let's say the EU community, but also from the bottom. So let's say citizen science and so on. So there's quite a lot of work that we do in this project, not only to develop further the concept, but also to have the full, I would say, interrogation or a full consultation, let's say, of the community as wide as possible. And then not only scientists, but also, again, managers, governmental operators, and also a lot of companies and industry groups. Now, this, let's say, done this discovery service, so it has been revealed a few weeks ago, and it brings together the different infrastructures here on the left. And the interesting thing is that these are in very, let's say, there's also now genomics in there, genomics and biology and ecology. Next to let's say the atmosphere, the carbon, and next to what I say more what for me was the common things, which is biology and let's say geology, chemistry, and physics. So we really try to bring together these different disciplines in a way, in fact, to build this data space, this marine data space, as you understand, and it's called databluecloud.org. So my conclusions is that as CData, let's say, we have developed and we are maintaining standards, which really are the glue by which we can bring together a lot of data from different organizations. We have a very large network, and this is still expanding. By this network, we have access to direct, let's say, to all those hundreds of collectors of data, and there are really thousands of them if you look all over Europe. And also we provide them then services for validation, but also for long-term stewardship, and also, of course, for wider dissemination and use of their data. And let's say, and what we also see, of course, is those who are collecting data are also big users of data, because there's always a reason why they do this. And that means that they're also being served themselves, and that keeps, let's say, the momentum. With these collections, we are able to make many derived products, more and more, and also we are able to build more and more dedicated analytical services. And this will really change the landscape. And we are right now, let's say, there is now an aim to go for a digital twin of the oceans, as they call it, really making a mirror of all the processes in the ocean. And this kind of work, what we do in the CData, but also in the Blue Cloud, is a prerequisite to be able to have a digital twin of the ocean, which really is working and is operational and will make always use of the long history of data, but also of the latest data. So this is what I would like to tell you. But like I said, it has been quite a journey for decades. But starting as a scientific project, I would say, over time, it became much more a society undertaking. And more, let's say, this is also recognized by industry partners and others. Any questions?
Thank you, Dick. Tanya has some question.
Mm-hmm.
Yes, thank you so much. Yeah, this is kind of like straight to the point, and I'm super happy that I heard your presentation, because it's I've been looking of the CDataNet and EMODnet and not all these different portals from user perspective, and it's quite confusing. Like the thing is, and now there's another one on top of it, and I think it's great, and like it's a nice set of data. But a straight question, like, where should you actually put your data? If you want to open, for example, Pentus data or BOI data, does it like go to the EMODnet portal? Or because I see that you have like super nice vocabularies and more kind of fair, like more from my perspective, like better approach. But this is like really hard when you look at the two different things, that maybe it's something that could be kind of user friendly because you come from like different perspectives. And it's just, my question is like, what is the right way
Where
to
starts?
use?
Where starts?
Yeah.
Yeah, okay.
Well, we have started.
Let's say we have an organization. Organization is collecting data. And first
we
of all,
we have long-term like Pentos data and BoI data from the zoological station in Finland, in Helsinki.
Now, as I know, in the CData network, we work together with what we call the National Oceanographic Data Centers. And those are, let's say, most of the time, major research institutes. In Finland, we work with FMI, for instance, and with Suke.
Yeah.
Those are our two entry points. And they are responsible, let's say, for the national collection or gathering. And that means that they can do two things, or they really host your data, let's say, and they do quality control, and they host the data in their databases and make it part of the European exchange. Or it appears that your institute is very capable itself of having a data center, and then you can also, let's say, open a node yourself with their help, and let's say manage your own data, but make it part of this European exchange using the same standards and guidance.
But this is the thing, you know, that universities, and in this case, like biological station, we are not, you know, the Finnish Institute. It's not. It's different kind of data, and opening that, and you know, it's just there are several ways. But for example, we have 100 years of Pentos data, and this has been opened like somewhere in one place, not so good one. And now, for example, we are going to do publications like a data paper, and we want to put the data in a proper place that is fair. So can you actually do it? Like can you do it?
If you talk about long-term biodiversity data, then we work with Eurobis. Let's say CData is one, Eurobis is another European infrastructure, and we work closely together. But Eurobis is really focused on the biodiversity, let's say, having a lot of collections from long-term, let's say, observations. And Eurobis is feeding into AMONET biology, while CData is feeding in AMONET chemistry, AMONET physics, and AMONET bathymetry. So we are, let's say, the engines behind those AMONET portals, because in AMONET, we bring together the scientists to make products out of the data. And so that's the added value of AMONET. But also, because we are making those products, which find their way easily to society, there's a lot of drive for others to bring in their data because they want to be on board of those products. So it's like an acknowledgement thing. Use my data and then also promote myself. And that's a little bit, let's say, the key. And at your national level, like I say, you can work together with the national institutes, which are the nodes, or you can work together with Eurobis. You can also have your institute part of Eurobis network, and then you are populating yourself the Eurobis. Yeah.
But I think here, I think we are kind of highlighting the problem here, that you have like so many places, and even like we are like.
No, I object to this. That's not true. It's quite clear because we built up a very good structure, and there are
but it's
infrastructures in Europe who do the work that we do. But a lot of people say they try to find their own way, and then they create an island instead of being connected, and that's the thing. So
and we are.
We don't agree that you say there are many options. There are not. Sorry, it's not true.
Well, I'm just trying to say that you mentioned all these institutes and everything, and I still don't know, you know, if I have 100 years of data, where I actually publish the data.
I make it very interesting for you. We have an AMONET ingestion. I'm running this. I'm the coordinator. You send your ID to me there. We have a network of 50 experts there in different domains, and we can together look at your question and give you a right answer, and then help you to set it up.
Okay, so it's the EMOTnet, not the C.
Sorry?
So it's the EMOTnet that we should contact, and not the CDataNet.
No, sorry. AMONET ingestion is set up now as some sort of let's call it's a service that we set up for those who are not yet connected and would like to share their data. So it's like a big Hoover that we set up, let's say, to make sure that those who are not yet organized and structured, that they also can become part of the party, I would say. And that's why I said write to me, because I'm yeah, I'm technical coordinator of AMONET, I'm technical coordinator of Blue Cloud, but I'm also the coordinator of AMONET ingestion. So I'm on all the levels, and if you send this message there, let's say, then we can help you, and then we can decide where to connect best. But well, there is only, like I said, it's very well structured over time. And
but it's just like, you know, it's hard to, just by looking, it's hard to know which path to go. You know, even we are working together with
I would say just a matter of sending an email. That's all.
All right.
Communicate. Don't complain, but communicate. That's the question, I would say.
Yeah, I'm not complaining. I'm just saying that it might be a little bit tricky for if I'm looking at from individual research.
But as I said, more than 850 people have already, or organizations already found a way. So it should not. There should be quite some experience in our case, let's say, to help.
Yeah.
All right. Thank you very much. And it's it's important to communicate. We have run out of time as usual, almost like to say. Thank you, Dick. Was there any other short comment, or can we close the session shortly? We had actually in the agenda last question that, okay, is there any need for the data space groups within the RDA, and if the people are interested in this kind of continuation and this kind of discussion. I see that, okay, there is 7 of us who has indicated this kind of interest in this collaborative notes. I think that we continue this RDA discussion because it needs this global approach and global point of views and so on. I propose that, okay, we continue this discussion offline, and I can send email to people and try to find what kind of continuation within this discussion might have. And thank you for all of those people who are interested in this kind of discussion. And because it was very nice to see that when Juan showed that there is not so big differences between RDA principles and data spaces and so on, but of course they are not totally overlapping. So there is possibilities to continue this discussion. But thank you for everyone, especially all of our speakers and participants and then so on. And let's have a look what's happening next. And as you know, closing plenary will start actually within 6 minutes, so there is a time to change that. But thank you everyone, and have a nice evening.
Thank you very much.
Thank you all.
Thank you very much. Bye bye.
Bye bye.